In this video, we're going to talk about how to calculate the standard deviation of group data. So here we have a class of students, and in a table on the left side, we have different classes of grades. 50 to 59, we'll say that's an F. 60 to 69 is a D. This is a C, and so forth. And to the right of that, we have a column that tells us the frequency of those values. So this means that 5 students had a score between 60 and 69, and 12 students had a score between 80 and 89. So with this information, where we're given the class ranges and the frequencies, how can we calculate the standard deviation of the scores that the students had, let's say, on an exam? How can we calculate the standard deviation given this information? The first thing we need to do is determine the midpoint of the class ranges. So what is the midpoint between 50 and 59? The lower boundary and the upper boundary of that first range. To find the midpoint, we basically need to average the two numbers. So we need to add them up and divide by 2. 109 divided by 2 is going to be 54.5. Now, if we average 60 and 69 for the second range, that's going to give us 64.5. And if we follow the pattern, we can see that the next one is going to be 74.5 and then 84.5. By the way, one thing I want to mention is that for this particular problem, the student scores that they received on an exam, we're going to say that all of those scores have been rounded to a whole number, because 69.5 is neither in this range or in that range. So we're going to say that all of the scores are whole number values or integer values. Now, we need to determine the midpoint between those two. It's not going to be 94.5. So we're going to add the lower boundary, which is 90, and the upper boundary, which is 100, divided by 2. So this is 190 divided by 2, and that turns out to be 95. So that's the first step. You want to calculate the midpoint of all of the ranges that you see here. Now the next thing we need to do is multiply the frequency column by the midpoint column. So this is going to be F times M. And let me give you the formula that we're going to use to calculate the standard deviation. The standard deviation is going to be the square root of the sum of the square of the deviations being the data values minus the mean, divided by n minus 1, where n is the number of data values in a list. Now, we're going to modify this equation for this particular type of problem. So whenever you're dealing with group data, you can calculate the sum of the square of the deviations by multiplying the frequency by the difference between the midpoint and the mean, and then you have to square those results, divided by n minus 1. So we're going to be using this formula in this video. So just keep that in mind. Now, before we calculate the standard deviation, we need to calculate the mean. The mean is basically the sum divided by the number of numbers in a list. For group data, the sum is going to be the frequency times the midpoint values, which is what we're going to get in in the fourth column. And then we're going to divide that by the frequency values, which is what we're going to get here. So notice that these two are the same. The sum of the frequency values is equal to the number of data values in the list. So let's get rid of this. Now let's multiply the frequency by the midpoint. So first we have 3 times 54.5. And so that's going to be 163.5. Next, we're going to multiply those two. So 5 times 64.5. That's 322.5. And then 9 times 74.5. I got 670.5. And then just repeat the pattern. So for the last one, 8 times 95, that's going to be 760. Now we don't need the sum of this column, but we do need the sum of the frequency column and the frequency times the midpoint values. So let's begin by adding up these numbers. So we have 3 plus 5 plus 9 plus 12 plus 8, and so that's going to give us 37. Let me just put a line right here. Now let's take the sum of these values as well. So I got a big number. I'm going to see if I can fit it here. It's 2930.5. So now we can calculate the mean. So it's going to be the sum of the frequency times the midpoint values divided by the frequency values. So it's 2930.5 divided by 37. And so that's about 79.2. Now, does this answer make sense? Do you think the mean is around 79? Well, notice that the bulk of the data is in this range. So 79 as the mean makes sense because most students, they scored between 70 and 89. So it makes sense that the mean is like around 79, 80. So now in the next column, we're going to put the mean, which is 79.2. And that's, of course, a rounded value. Now, for the next column, we're going to take the difference between the mean, not the mean, but the midpoint and the mean. X bar is the mean. So let's subtract 54.5 by 79.2. And so we're going to get negative 24.7. Now let's subtract these two numbers. So 64.5 minus 79.2. Now let's subtract these two. So that's going to be 74.5 minus 79.2, and so that's negative 4.7. And then we have 84.5 minus 79.2, and so that's positive 5.3. And then for the last one, 95 minus 79.2, that's going to be 15.8. Now we don't need to add up those values. For the next column, we're simply going to square the previous column. So basically, we're going to take negative 24.7 and square it. So it's going to turn into a positive value. It's going to be 610.09. 14.7 squared, that's going to be 216.09. And then 4.7 squared is 22.09. Next we have 5.3 squared. This is going to be 28.09. And for the last one, it's 249.64. Now the last thing we're going to do is we're going to multiply the frequency by the square of the deviations. So this is going to be f times m minus x bar squared. So it's going to be 3 times this number. And so that's going to be 1,830.27. Now let's multiply 5 by 216.09. And so you should get 1080.45. Now this work is pretty tedious, but this is how you would do it if you're not going to use Excel or a calculator. For the next one, we have 12 times 28.09, and so that's going to be 337.08. And for the last one, it's 8 times 249.64, and so that's 1997.12. Now, we do need to take the sum of that column, so let's add those 5 numbers. And so you should get 5,443.73. Now that we have the sum of the frequency times the deviation squared, we can calculate the standard deviation using this formula. So it's going to be the sum of the frequency times the square of the deviations divided by n minus 1. So this number represents everything that you see here. So we're going to replace this term with 5,443.73. N is this number, 37. So we have n minus 1, or 37 minus 1. So it's going to be 5,443.73 divided by 36, because that's 37 minus 1. And so that's going to give you 151.2147 with some extra numbers. And then when we take the square root of that result, our rounded answer, so it's going to be approximately 12.3. So that's the standard deviation for this grouped frequency data. And that's how you could find it for this type of problem. Thanks for watching.